This week on the show, we cover backup and restore on NetBSD. OpenBSD 6.7 is available, so we covered that. We have an article and tutorial for you about building a WireGuard jail with FreeBSD standard tools. We cover a little bit who gets to own things and quotas and all these interesting stuff that happens in the system. We have also the TrueNAS CORE roadmap for you, as well as other interesting bits and pieces in this week's episode of BSD Now. BSD Now, episode 351, Heaven, OpenBSD 6.7, recorded on the 20th of May 2020. Hello, I'm your host, Benedict Kreuzling.
And I'm Alan Jude.
Welcome to this week's episode. Hope we're all well and good, because we have great headlines for you, as always. The one we picked first is Backup and Restore on NetBSD.
Yep, so this is over on a GitHub blog, and the user goes on and says, putting together the bits and pieces of a backup and restore concept, while not being rocket science, always seems to be a little bit ungrateful. Most admin handbooks handle this topic only with a few pages. After replacing my old Mac Mini OS with NetBSD, I tried to implement an automated backup, allowing me to handle it similarly to the time machine backups that they would have had on Mac OS. Suggestions on how to improve are, of course, always welcome. So some thoughts on their strategy. They say the first thing you probably want when reading about these topics is the advice, don't have a backup strategy, but a recovery strategy. That is, make sure your backups are actually in a usable shape and be sure you know how to apply them in an emergency. Depending on how much you value your data, you might want to store the backup media in a physically remote place. At least you should not store it in the same disks to be backed up, but on detachable media or on a remote computer. Also, it should be set read-only after the backup is finished, so it can't accidentally be damaged while accessing it. The next question is about how much time and space you want to dedicate to your backup. When doing a full backup each time, recovery is easy. Just apply the latest backup. On the flip side, each backup might take a really long time and much storage space. So on the other extreme, it would be to start with one full backup and afterwards only doing incremental and differential backups. Then, of course, the restore is expensive, as you need to apply each of the incrementals on top of the original full to get to the latest backup. So tools like rsync mitigate by merging each increment into the previous backup, making a copy of the backed up file system, but this collides with the requirements of not modifying the previous backup and of wanting to be able to say, oh, I didn't realize that file got corrupted yesterday, and then we backed it up last night, so this morning I can't restore it to the previously uncorrupted state because I've now backed up the corrupted version, and rsync was only keeping one copy. And that's why just a copy like an rsync is not really as good as a backup. So then you have tools like dump for UFS and FFS and similar, and it suggests to do the next incremental only every nth time, for example, every second time. That is, to generate the diff of the same preceding backup for the following two consecutive backups. Besides that, it suggests generating weekly backups incremental to the original full backups. Finally, it suggests to build a new backup every 4 weeks, this way to maintain your 3-level strategy of stacked increments. If you have a full backup once a month or whatever, and then differentials once a week and incrementals once a day, you will never have to apply, if you had just incrementals, you could have to apply 30 different backups to be able to restore. Whereas with the, grandfather strategy of full differential and then a bunch of incrementals, it would mean that you'd never have to apply more than one full, the differential, which is everything from the full to that point. So then you'd be in the right week, and then, just a couple of incrementals to get to the day without having to do, 30 incrementals or whatever. But dump gives you quite a bit of flexibility, allowing you to do level 0 all the way up to level 9, I think, or 7 at least, and, make up whatever kind of strategy makes sense for you. But of course, dump only works on compatible file systems, but UFS is one of those. So now when you want to access a remote backup device, you can do dump over SSH, and then, can reverse that to do restores that way as well. Or you can use something like SSHFS to just write directly to a file that's on a remote host, or a bunch of other similar options. Or you can use snapshots. UFS has snapshots, although they're not really the same as ZFS snapshots. But the other main thing to consider when doing a backup is if your data is changing while you're backing it up, you don't actually have a consistent backup, especially if you have anything like a large file. If you have a VM running, when you start reading the VM image, if it's many gigabytes, by the time you finish, the middle has changed. And so what you actually have is a corrupted file system of your VM. Maybe it'll be okay, but maybe it'll be quite problematic. And so if you can create a snapshot, even with UFS, if you back up that snapshot, you know that during the backup, none of the files are changing because you're backing up the snapshot, and it will give you a much nicer backup. Even if you're, just using tools like dump or rsync, backing up the snapshot will give you a much more consistent version of the file than you would get otherwise. I think dump includes it by default, don't they? I don't actually know. I admit I've never actually used dump as a backup strategy. But they have some examples further down, so if you just want to get to what do I got to do to make this work, they show how that can happen, and they built a shell script, which they appended onto the end here. So if you want to, have all their logic already applied for you, it's quite useful.
And also with snapshots, you get the whole permissions and ACLs, whereas with dump, you have to make sure that all of these are included as options. Yeah, the examples for each of these invite tests, so you can just right away copy and change them to your needs without having to figure out, oh, which options do I need for that? So you can just start away and make sure you test them out for a while and then see which ones suit you better. Okay, I like that. Okay, then next we have the namesake for this episode. The OpenBSD 6.7 release is here, punctual as ever, because that's OpenBSD's way of the release cycle. And of course, with nice artwork and all the other extra things you would get from OpenBSD. Released on May 19th, so just one day from the time of this recording. And there is plenty of new things in there. Of course, it's a major release.
Yeah, looking at it, I see that their concat volume manager can now work with just a single chunk, which can be useful when you want to be able to add more chunks later. And that BioCTL changed support from a maximum of 7 to a maximum of 15 volumes that can be created on a single disk, allowing you to have a lot more partitions than you could before. That can be important if you are, if it's a VM or cloud image and you're going to keep growing it over time, it might make a big difference there.
Yeah. So there's a whole big list in OpenBSD's changelog, of course, which we've linked for our show notes. Of course, it's a bit much to go through each item, but the general overview has it look like it's very, very well polished. So they have general improvements and bug fixes, of course, at the beginning. So that's a whole long list. There's a bunch of changes to the DH client. For example, releasing leases without a server identified, or having not sending endless request messages when an ACK is never received. So that's some good things behind the scenes in your network stack for DHCP.
I also noticed their soft RAID crypto volumes now work properly on 4K sector disks, where doing 512 byte reads or writes would actually return an error.
Mm-hmm. They also switched the default compiler on PowerPC to Clang, so people need to be aware of that if they want to compile some binaries. And the small things here, not too shabby. They implemented scrolling in top using the 9 and 0 keys.
Interesting. That's not a bad idea. Then they also now have FFS2, the newer version of the file system, which supports 64-bit timestamps and 64-bit block numbers or inodes, and is now the default for all new installs on almost every architecture. I think it's like Luna 88K and SGI, a couple that don't support it. They changed the Spark 64 boot blocks to be able to read from FFS1 and FFS2, as well as soft RAID, and enable FFS2 option for both of the floppies for Spark as well. And they taught, i386, Mac PPC, HPPA, Alpha, and a bunch of others support for reading from FFS2. They also fixed a problem with the partition reading code on Alpha for dealing with offsets of more than 2 gigabytes. And the ARM64 and ARMv7 EFI boot also got support for FFS2.
Okay.
getting those out from underneath the kernel lock.
Then there are SMP improvements. The bunch of functions in the kernel and what are they called? System calls, yes. So they are run without those, so that's a bit faster this way on multiple processors. And they made some VMX transmit MP safe improvements, or made it overall MP safe.
And the AMD symmetric multiprocessor / core / package detection stuff, which helps prevent cores being misidentified as threads and then being disabled by the default of not having hyperthreading on OpenBSD. So yeah, some improvements for the new AMD hardware.
Speaking of hardware, a bunch of new hardware got updated, or drivers written in the first place. So there's a happy list of new devices now working in OpenBSD better than before.
Yep. Improvements to the EM driver, which is the Intel 1 gigabit. Added the URE driver for Lenovo one line plus Ethernet that's built into the dock for a lot of Lenovo laptops. So that's a good one to have.
Mm-hmm. There is some ACP vout changes for the screen brightness adjustments. So you can use the function keys to better support the machines using exponential brightness scaling. And the scaling itself is in levels of 5% or higher.
Yep. They removed some drivers though. Some old IBM PC boards, old-fashioned ATA SCSI rate, some old PCMCIA cards, and the Apple Power Macintosh SCSI card.
Ah, those.
Nothing anybody would be using anymore, so it was good to get those cleaned up.
Yeah, no one will miss those.
Lots of improvements to their audio driver framework, SNDIO, so that's good.
Yeah.
Improvements, lots of drivers added for the ARM64 and ARMv7 hardware support. There's a giant list in the changelog there. Wireless stack improvements, generic network stack improvements, installer improvements. Unveil is now used in 82 userland programs to redact file system access. They've extracted dig, host, and NSLOOKUP from the bind source code and cleaned up the source code by removing not needed features and auditing it. So now the kernel API accessible by these programs is now restricted through pledge as well. So they basically have forks of dig, host, and NSLOOKUP in base, which is one way to approach it. I think in FreeBSD we replaced them with the drill, which is what, LDNS or something. But yes, I miss dig sometimes. So that's a nice approach. It's not like there's a lot of development in dig where you need to worry about diverging from upstream, right?
That's true, yeah. Yep, further improvements are in the routing and userland network improvements.
JSON output in BGP CTL. And yeah, lots of other improvements around networking and userland stuff, including support for VXLAN, GPE, and TCP dump, more ifconfig stuff, SNMP stuff. The FTP/HTTP client is improved, and the RPKI client for doing signed BGP stuff is improved as well.
Mm-hmm.
VMM/VMD, their hypervisor, got some work. More Spark64 virtualization improvements. Imported OpenSMTBD 6.7, which includes new features, bug fixes, and experimental features. The latest release of LibreSSL 3.1.1, which adds the TLS 1.3 extensions, bunch of that. OpenSSH 8.3, which has a list of the possibly incompatible changes. For example, SFTP rejects the argument -1 in the same way that SSH and SCP do, instead of accepting it and silently ignoring it. Remove support for SSH RSA with a SHA-1 from the list of allowed certificate authority signature algorithms, and removed the known bad Diffie-Hellman Group 14 SHA-1s as part of the key exchange, and more. I think we covered all that in the 8.3 release earlier.
There are unbind improvements as well as IPsec improvements as well.
Mandoc improvements, ports and packages improvements, where they have over 11,000 ports for AMD 64 and almost as many for ARM 64. Only maybe 500 less out of 11,000. That's
a lot.
That's good work. Plus, they updated their version of Xenokera to be based on Xorg 7.7 with Xorg Server 1.20.8. Plus lots of fixes, Mesa 19.2.8, etc. They're on Clang/LLVM 8, GCC 4.2 and 3.3, and they've updated Perl to 5.30, Unbound to 1.10, etc.
You find update instructions as well as extra last-minute changes, of course, in there as well. And if you like the release, definitely consider a donation to the OpenBSD Foundation. And yeah, I think that's a decent release. If you have installed it already and tested it for a while, then we would be happy if you would either write a little like blog post about it, how your experiences are, or send us a little bit of feedback to feedback@bsdnow.tv, and we'll cover a little bit more about OpenBSD in this show. All right, it's time for the news roundup this week. We have a how-to article for you about building a WireGuard jail with the FreeBSD standard tools. So this one is, of course, about the popular WireGuard VPN solution that a lot of people are using, and it's becoming very, very popular. So this is the tutorial for you. They had the opportunity to build a WireGuard jail on a FreeBSD 12.1 host, and it was really quick and easy to set up, they write, and it has been working completely fine for a month. So I'd like to share the experience with anyone interested in this topic. I had a bunch of notes at the beginning, but I will skip about them for now. So let's just start with creating the jail. Since this article is about FreeBSD space system standard tool, you can just run them there. Well, sudo is not in the base system, but you can probably switch to root for this one as well. So to start with, you would have to create a jail's file system from a template ZFS snapshot. So they sent, in this case, the zroot from a 12.1 version, well, there's a snapshot p3 to ZFS receive. Oh, I see. This is referring to an earlier article for details on how to create that template. Okay, so they start off with something that
Right, but basically they installed 12.1 p3 to the jail.
Yeah, that's a...
You don't have to do it their way. Any way will do.
Right, that's a separate article. So this is just the base setup. Imagine after this point, you have your base template available. And then you configure the internal network, because what they did here, they created a bridge 0, for the internal jail network, which is 192.168.20/24, and an e-pair, which is e-pair 0A and B. So one pair of the e-pair is connected to the jail, and the other one is to your main host. Attach the B side of the e-pair to the bridge and assign an IP address to the bridge. And adding the IP address to the bridge 0 makes it the third routed interface on the host, and the address becomes the default gateway for the jail. You would do this in rc.conf with a cloned interface entry, as well as an ifconfig bridge 0 and an ifconfig epair 0b to set both up. There's a nice diagram so you can see how the networking works and which is connected to which and where the bridges are and the epair is connected to. And so they use the bridge so that they can add more jails to the internal subnet in the future, as shown in another diagram. And if you only need a single jail just to get started, it's not necessary to use the bridge. You can connect the jail to the host directly with the epair by using another configuration they provided. So you just do the cloned interfaces, epair 0, and then provide ifconfig epair 0b with an with an IP address. There's a separate diagram for that for comparison. Very nice. And then you adjust the firewall rules in your pf.conf in this case. You would set the firewall rules for the jail and the WireGuard subnets. You define a couple macros for the internal jail and WireGuard subnets, and then tell them that outgoing packets from the jail and the WireGuard subnet should go to the NAT target. Another redirect port forwarding rule is established to redirect the incoming UDP packets destined to the port 51820 to the host public IP address for the jail, and allow incoming packets from the jail, which is your general pass-in rule for everything else. Next, you configure the jail on the host. You edit a defs rule to add a little subset or rule set there, which requires the jail to create the WireGuard interfaces. So you just add a defs rule set there and add BPF unhide to it. Next, you create the etc jail.conf to add the basic config for the WireGuard jail, what this should look like and what kind of interfaces it should have, and some extra settings like allow change flags, for example. Then you would edit rc.conf to enable the jail on system startup. Always good to have. Never forget this. Otherwise, when the next reboot happens, your jail won't run automatically. Jail enabled equals yes, and jail list the jail you have in question. In this case, it's called WG, WireGuard Jail.
Right, you can have a space separated list there.
Right, yeah. Otherwise, it's mushed together and the system can't figure out which is which. Then on the jails file system, you pre-edit the jails rc.conf to configure its IP address, then the default gateway, and enable packet forwarding so that this knows where the packet should flow with 3 little entries in rc.conf. And then you apply the configurations and start the jail. So it's netif clone up, service pf reload, and service jail start. Then within the jail, you install WireGuard and configure it using packages.j option. So you can nicely install that from the outside into the jail.
Yeah, it allows you to install a package in the jail from outside.
Yeah. And then you do the rest with a couple of jexec invocations. So you just from the outside make some changes inside the jail without actually switching into the jail and get the shell there. You just do everything from the outside. You set up the interfaces that's shown for an example Android configuration, but you can, I guess, switch this out to any other device you might have. And then last thing is, of course, in this case, the Android device. You install WireGuard app from Google Play Store and then configure and point it to your new server.
Yeah, and they even cover how to use the QR code stuff to pass the configuration to your Android phone instead of having to type it in on the phone keyboard.
Cool.
Because typing in the private key or something would be really annoying.
Ah, yes, much easier. So yeah, straightforward, not too difficult, I guess. And I think that should also be possible to adapt it to a different network or to a bigger setup.
Mm-hmm. Yeah, it's similar to what I did, although I think I had to unhide the tap interfaces in the DevFS as well.
Okay, that could be, yeah.
So that WireGuard could create the different tap interfaces. Anyway.
Then we have, as a next news item, the UNIX divide over who gets to change own things and disk space quotas. This is over on Chris Seiberman's blog, which we've covered a couple of articles already, so he always has some interesting things to say and writes about them.
Yeah, so he says the UNIX divide over who gets to own things and how that applies to disk quotas. This one came up for me recently, and I'll talk a bit more about that at the end. So he says, one of the famous big splits between the BSD Unix world and the System 5 world is whether ordinary users can use chown, the command and the system call, to give away their own files. In System 5 derived Unixes, you were generally allowed to do this, but in BSD derived Unixes, you were not. Until I looked it up now to make sure, I thought the BSD changed this behavior from v7 to that v7 had an unrestricted chown. However, it turns out to be wrong. In v7 Unix, chown was restricted to root only, and the man page even says so, saying only the superuser may execute this call because if users were able to give files away, they would defeat the non-existent file space accounting procedures. So quotas didn't exist yet, but they are already thinking about how users would give their files away in order to not have this thing. I remember also at college, we had the interesting thing of not just chown, but chmod. So they actually made it so that each user didn't own their home directory. They were just in a group that had write access to their home directory. So they couldn't chmod their home directory to allow their friends access to their files.
Oh, cool.
Stuff like that. But anyway, it says v7 didn't have any direct support for disk quotas or file space accounting, although you could put together various things to at least monitor who was using how much space by sweeping over the file system. Anyway, in 4.2 BSD, the UCB CSRG added disk quotas. And he says he believes this was part of the new 4.2 BSD fast file system, or FFS. And so they kept the restriction on chown. Now that they had real disk quotas, the threat of undergraduates and other people defeating them with chown was quite real and had to be avoided. He notes that the original 4BSD didn't have disk quotas, but it did have the quot, or quote without the E command, to analyze the file system and tell you per user usage information. So this area was on the CSRG's collective minds for a while. It operated by scanning the raw file system to the disk as per the source code that he linked. Meanwhile, on the System 5 side, the restriction on chown appears to have been lifted under System 3 or 32V Unix, because 32V Unix still had it. I don't know why it was removed, but System 3 had no disk quota system, and the change is clearly deliberate. the chown man page has been updated to document the new state of affairs. This was carried through to System 5, where it became well known and common as System 5 spread. All of this left POSIX with a little bit of a mess. Which POSIX solved by allowing both behaviors in the POSIX chown specification. In fact, POSIX goes further than a system-wide choice. Things may differ on a path-by-path basis, with some paths permitted normal users to give away their files and some not. That makes sense because you might want to do it on a per file system basis. If the file system supports quotas, maybe it wants to enforce this rule, and if it's a file system that doesn't, maybe you don't want it. It says, in fact, the rationale section of the POSIX chown specification has a thorough recounting of a historical difference that led to the situation and confirms that normal UIDs being allowed to give away ownership was the System 3 edition. Pretty much all common modern Unixes have come down on the BSD side of this divide. The BSDs inherited the original v7 and 4.2 BSD restrictions on chown, and Linux copied and adopted those. Illumos inherited the System 5 R4 through Solaris and appears to have a chown that by default follows the System 5 behavior by allowing anyone to give away files. However, its chown man page documents a system-wide way to turn this off in allowing other options. He says, it's my view that a restricted chown is the right choice even if you ignore disk quotas, but that's another entry. So sidebar, how to safely defeat disk quotas by chowning away your files. Because this may not be obvious, let's suppose that you are an undergraduate on a system that implements disk quotas based on file ownership, but permits you to chown them to other people. Then you can get around your disk quota as follows. Make a restricted directory somewhere. Perhaps you call it, home/assignments. No one is going to fault you for making that only accessible to you. Now, create your big files in this restricted directory or a sensible subdirectory of it, making them world readable, or perhaps only group readable if to a group that you're in, and executable if necessary. You can also make them writable if you need to. Then pick a victim user. Let's call him Barney. chown all of these files to Barney, who suddenly gets charged for your storage space. But because you're in the group, you still have access. Is that you retain access to these files through Barney, who owns them, because giving them away didn't change their file permissions or any of that. Barney doesn't have access to them because they're hidden away inside an inaccessible directory. Standard Unix gives normal users no way to find such files to manipulate them once they have found them. And if you need to make the evidence go away or just change things around, you can delete the files because you still own the directory that they're in.
Oh, that's neat.
Yeah. So what's interesting there is I had a similar problem. I needed users to be able to upload files via the website, but I wanted the files to end up owned by the user. A, for the accounting, but also B, so that when they later logged in, they'd be able to delete them and so on. So suddenly I had this, file upload user who needed to be able to give files away, which again, normally isn't allowed. Luckily, I was able to make a FreeBSD MAC or mandatory access control module to basically make a special rule on my systems by loading this kernel module that says, if your user ID matches the value of this sysctl that I created, then you're allowed to give away files as long as you currently own them. So basically, this user can give files to other people, although it can't give files to root or change the ownership of files it doesn't own. I kept it locked down because I didn't want somebody to be able to, make a set UID binary and then chown it to root or something silly.
So I like one of the comments here by OPK. Goes like this. Back when I was an undergraduate, I think I was owning my files to root or nobody rather than picking an actual victim. And we made good use of hiding files below var/preserve, which was where VI stored backup files until one idiot filled up the physical disk that was on. Yeah, the tales from the Unix crowd. From way back when. Yeah, but definitely it's a good read about, the whole problems with the quotas and disk space being a short resource.
Yeah, because of the way the quotas do work on ZFS, I wonder what Illumos does there.
So there are general quotas for data sets, and there's also user and group quotas.
And so the user quotas you could defeat if you can chown the files.
Yeah, easily. Yeah. Yeah, which is the best solution for the user? It's like, I want my partial file back.
I'm not sure what happens there. If you own the file, you snapshot it, and then you CHmod the file away, and it grows or whatever. Like, does the most of the storage get billed to the person who owns the file, but the little bit of the changes that have been overwritten, so a couple of blocks of the old file that aren't shared, then get billed via the snapshot to the person who owned the file when the snapshot was created?
Yeah.
Like, it's not important, but it's the type of thing you could spend an hour trying to figure out.
Yeah, that's a mess. Yeah.
Well, it's like, do we just say whoever owns the file now owns that whole object, or does it change over time? And all kinds of interesting questions can come up there.
Okay, let's see what's next in our list. Oh, you mean the TrueNAS Core roadmap thing? Okay, that sounds good. You can influence the TrueNAS Core roadmap. It turns out this is on IX Systems blog about TrueNAS bugs and suggestions.
So yeah, so this is dear FreeNAS and soon to be TrueNAS community. We're making some changes to the FreeNAS and TrueNAS bug trackers that'll give you yet another way to help contribute and democratize enterprise storage. As many of you know, we've historically had 3 ticket types available to our tracker, bugs, features, and improvements, which are all fairly self-explanatory. After some discussion internally, we've decided to implement a new type, suggestions. These will be replacing feature and improvement requests to the TrueNAS community, simplifying things down to 2 options, bugs and suggestions. One issue we've had in the past with features and improvements is that just about all the ideas submitted have been good ideas. The challenge has been determining which ideas are best or most desired by the community, which at the time made it difficult for our engineers to determine which one ought to be integrated into the development roadmap. Just because we think something is a good idea or a community member submits a well laid out feature request, we didn't necessarily have a great way to determine which ones would have the biggest impact. So now bugs go through this little flowchart they have here where they gather interest and people basically submit votes to certain ideas to decide which ones they would like to be the most considered. Then IX reviews those and then either accepts or rejects the idea and then goes through and becomes a new epic in their development setup. And the feature and improvement tickets actually get created and they start building the feature.
Ah, I see. Okay. So to provide such a suggestion, you would log in into the ticket system and then find your issue, or if it's already existing, and click the vote for this issue link on top right for each ticket. You can find a suggestion that addresses your issue, create a suggestion, let us know why it's important to you, they write. Yeah, I see that from some of the bugs in the FreeBSD bug tracker that I recently went through. So some of those are more, I would like to have, or wouldn't it be great if, rather than, oh, this is something not working or that should be fixed. So it's kind of difficult to kind of distinguish wishes and improvement requests with actual bugs that are appearing. But yeah, this might be a way for people to bubble up more important things on their mind before the developers, rather than just putting them in there in some kind of system that they all start running in at some point. But yeah, we'll see if that is a nice way of bringing some of the user-contributed suggestions into the TrueNAS Core. All right, time for the Beastie Bits this week. We have a FreeNAS spare parts build, which is a YouTube video testing ZFS with imbalanced VDEFs and mismatched drives.
Yeah, so that's an interesting video if you want to go check that out. It's about 27 minutes long.
Yeah, the mismatch can easily happen if some drives are dying, and if you misconfigure your pool from the beginning without using the N option to show you what would the pool look like. So this is a thing that could definitely happen.
Unbalanced lens can happen when you add newer disks, like if you just expand the pool, or if you replace older disks with bigger ones, but only some of them and stuff. You can end up with, some disks in your pool almost full and some of them mostly empty. And especially in ZFS before FreeBSD 11.2 or 11.3 even, this could cause quite a few problems.
Okay. So good to know about those. Next, then we have TLS version 1.3 server code enabled in LibreSSL in OpenBSD current. This is over at Undeadly, of course. From the TLS freshly served department, they have a commit featured here by Joel Singh, which enabled the TLS version 1.3 server code in LibreSSL current. And the client code was already enabled in current and will be in the 6.7 release, which we covered in this episode earlier. And they thank Joel, Bob Beck, Theo Bühler, and others for the hard work. Cool, some fresh TLS code. Always good to have.
Yep.
Then next, we have an interview.
Yeah. The downside to forking OpenSSL is you have to, work on each new feature to bring it over.
Yeah, yeah, definitely. An interview we have next with Deb Goodkin, Executive Director of the FreeBSD Foundation, on itsfoss.com.
Yep. So if you're interested in that, go check it out.
All right, time for the feedback and questions part of this episode, which a lot of people are looking forward to, or skip ahead to. Well, they missed the rest of the show, but that's your choice. People send in all kinds of questions to feedback@bsdnow.tv, or want to have advice or whatever help we can provide here. The first one, and a repeated question sender, is Boston here, who has a question about WireGuard, which we also featured in this show earlier. But he writes, "Hi, Alan and Benedict and JT, and any guest that might be present at the time." Okay, yeah, that's good. Kind of covering everyone. I have a short question about WireGuard. This question is both for you and also JT is welcome to answer it. Do you use WireGuard in any of your systems? Why, yes or no?
So yes, I have set up a WireGuard jail on my home NAS so that I can connect in remotely. Main reason is the setup is just a lot easier than something like OpenVPN. I don't have to build a certificate authority or anything like that. And it's kind of, newer and lighter and faster. So yeah, I like WireGuard. There are still some rough edges, like when I installed it, which was a number of months ago now. It didn't really support dynamic addressing stuff. So like if I created 5 users, I had to give each of them an IP address. And the same user couldn't be logged in twice. It'd be nice if it could do something like DHCP, but I'm not that picky.
Okay. I haven't had the pleasure yet, as I hear a lot of good things about WireGuard. So I use mostly the VPN into the university these days, and Shuttle, SSH Shuttle. I don't know how you pronounce it. It's Shuttle with SSH in front, because that's kind of the way for me to go to all the systems in the university that I need for my daily work. But if I ever go back on the road again, whenever that might be, WireGuard might be an option for the the hotel or train station where you don't have a secure Wi-Fi, and WireGuard might be the solution for me. Since I read the tutorial earlier in this episode, I might be tempted to try this out myself. Then the second related question: I haven't seen any news about WireGuard getting into FreeBSD base system. Do you know if it will get there?
Yes, I'm very sure that Netgate, the company behind pfSense, is funding some work to get the WireGuard kernel side stuff into FreeBSD. I don't know the status of it off the top of my head, but I do know that it is something that is being done.
Yeah, I think there was something in the recentish quarterly report about that. Someone
Probably
working on it.
Yes, but somebody is working on it.
Yeah.
And hopefully it'll be there soon.
Was there something in the Fabricator?
The Go-based version works fine, so
Yeah, so there's no...
I'm not too concerned, but it'll be nice when it's built in.
Yeah, there's no like license block or something that would prevent such a thing. It's just someone needing to sit down and do the missing bits to integrate that.
Right. Well, I think that they're even focusing on making it very fast. So
yeah, and definitely having that as a kernel or as a base system item would be very good in that regard. So yeah, that's WireGuard. If you have any experiences after maybe trying it out, then definitely send us a follow-up. And if other people want to chime in about their WireGuard experiences, definitely send this to us as well. And yeah, thank you, Boston, for your question. And next is a chat with a ZFS pool design question. Here goes chat. Alan, okay, addressing Alan because ZFS. I recently acquired a Dell R6010 with dual Xeon 96GB of RAM and 3 HP D2600 fully populated with LFF 2TB drives. 72TB raw total. Oh, wow. For my home lab. I'm planning to replace the 6 internal R610 SFF drives with SSDs and use 2 for mirrored Z root. Quick question about that. Can I build Z root on HDD and replace it with SSD, or should I really build with SSD from the start?
It's fine to swap the drives later. It won't make a difference.
Yeah.
As long as the hard drives aren't bigger than the SSDs are going to be. So if you're going to start with hard drives, you might want to use a, normally you would anyway, to boot off of it. So, keep the partitions smaller than whatever the SSDs are going to be so that you find especially SSDs tend to come in odd sizes. Like sometimes they're 480 gigs instead of 500 gigs or whatever. So you might want to undersize the partition on the hard drive. You can always grow it to whatever size the SSD happens to end up being. But you just want to be careful that you don't end up with SSDs that are, 100 megabytes smaller than the hard drive was, and then you have problems.
Mm-hmm. Yeah, and if you're just starting out with this machine, it won't have much data on it, just the base operating system install.
Right, and so the resell will be quick. Exactly.
Yeah. Okay, so 2 are for the mirrored Z root, and the other 4 for the slog or L2 arc. Okay, then
that will depend. Like your slog never needs to be huge. Like just doing a small amount of the drive and leaving the rest blank and letting the wear leveling handle it will work. Just it never makes sense to have many tens of gigabytes of slog. It's just never going to need that much. And then L2 arc, 96 gigs of RAM is lots, but it's not a lot either. So it might be doubtful whether the L2 arc is going to help you that much. If you're running new enough FreeBSD, I don't know if 12.2 when it comes out will have it should. So once 12.2 comes out, or if you're running head, you can use the new ZFS special VDEVs, which would let you create a mirrored pair of SSDs and have just the metadata for your file system on those and the data blocks on the hard drives. And that might give you a bigger performance boost than having, half a terabyte of L2 arc or something like that.
Cool.
So it depends on your workload. The L2 arc might work well for you, but it might not make that big of a help.
Mm-hmm. Okay. So Chad purchased the storage bundle on Michael W. Lucas' website, of course, in hopes of gaining some insight into how to slice and dice the drives up. I'm currently reading FreeBSD Mastery's ZFS book and certainly picked up some good tips so far, such as drive labeling and ensuring ZDEVs, or VDEVs probably, are spread across enclosures, but I'm still unsure of how to configure the pools in VDEVs for this setup.
In general, you just pick your layout. Like if you're doing RAID Z2, then pick a width that works for you and slice up the drives that way. The Matt Aaron's article, how I learned to stop worrying and love RAID Z, has a spreadsheet that can help you pick which width of RAID Z will give you the best space efficiency for your block size and so on. If you're mostly storing Plex stuff and you're going to use 128K or 1 meg blocks, it's not that big of a deal.
Mm-hmm. Yeah, he writes a bit about his intended use. The primary purpose of this system will be hosting Plex and running other jails and or Beehive instances to provide some additional services. Git repos, Moonin, NFSN, LibreNMS, Prometheus Grafana, Elk, Suricata Bro. Why do you need Moonin and Prometheus Grafana? Okay. Your choice, as well as experiment with new apps and tech. We made some recommendations already configuring for this setup.
Yeah, so the biggest recommendation I would say is if you don't need a lot of space, if you configure you have like 30 some odd, 36 hard drives, configure those as mirror sets, you will get more performance, especially if you're going to create zvols for like the beehives. Where RAID Z and zvols, you can end up wasting a lot of space if you have a small vol block size, which you might want for the beehives. So, mirrors are the best, but at the same time, but you will get less of that 72 terabytes of raw space. So you might decide to use RAID Z to get more storage. But if you're more worried about performance and flexibility, then the mirrors give you more options.
Yes. Yeah. And in general, I would recommend you probably finish reading both books and then maybe think about your setup once again. But it's not a problem if you made things not the way you like it at the end. You can still rebuild everything.
Yeah. The other option is create a pool with just, 10 or 12 of the drives or something and start playing with it. And then as you learn more, you could recreate the pool, create a new pool out of the rest of the drives, migrate your data over to the new pool, then delete the old pool and expand the new pool by adding those disks to it or whatever.
Oh, yeah. But that way you can also learn about send and receive.
You have 36 drives to play with, so maybe you want to try a bunch of different things and just play with it, right? If it's just for your home lab, there are advantages to just doing lots of different things.
Mm.
The biggest one would be think ahead. Your Plex data might be relatively big, and so you want to make sure you don't have to try to back up and restore it or something. So try to keep a bit of flexibility so you can move stuff around and recreate your pools if you want to try different setups.
Yeah. And just create a data set for each new thing and then put everything there so you can keep it nice and separate. But yeah, good luck with your ZFS journey with the server. And if you have further questions or have something to show to us, maybe your final setup then, definitely let us know to feedback@bsdnow.tv. We're always looking forward to kind of, what people build with ZFS and what kind of cool things they're doing with their setup. All right, then, last but not least, is it Pedro or Pedreo?
I think it's just Pedro.
Not sure. But that person has a question about scaling FreeBSD jails. Goes like this. Hi there, another question for ye. I regularly hear you speak highly of jails and also use them in a basic way for simple tasks at home. Is there a robust way to scale jails similar to how Linux containers do without the need for some homemade bash script or shell? Is Ansible the best route to take?
So I guess it depends what you mean by scale. Like, do you mean automatically start more jails on different hosts to handle load, or you mean just it's easier making it simple to manage 10 jails at once? If you just want to manage a lot of jails, then yes, Ansible or something is probably the right thing. I don't use any homemade bash scripts on any of my stuff.
Yeah, or if it's just the management solution, because you kind of grow more jails and you can manage them, look at different solutions like EasyJail or IOCage that give some of you some of the flexibility to you to create like many different jails in an instant with a different configuration for each of them. But yeah, the scaling of Linux containers is a different story. Definitely jails are not there yet, but some of these things are kind of overblown and not everyone needs a AWS-like data center at home. Although some people would like to have, but it's a lot of stuff to manage and keep track of in this kind of environment. So that's a whole different playing field. But yeah, if anyone else has something in like a home build solution or found something on the web that does FreeBSD jail scaling, whatever that might mean, then and we haven't covered it yet on the show, then let us know and we'll be happy to feature it. All right, then thanks for this question, and that pretty much covers this week's episode of BSD Now. Thank you for listening and stay tuned for next week's episode.